morning, students. Welcome to KUTV Elimu Live. Today for secondary mathematics, we are looking at Form 1 mathematics, and we are discussing a topic we call fractions. Fractions is covered as topic number 6 in Form 1, just immediately after the topic we call integers. And as Form 1s will tell, that these topics are just done the same way as they are taught in primary school mathematics, and but we only add few things, and those few items that we add to make it a bit different from the primary fractions are the ones that I want us to discuss in our lesson today. Because most of the things like operation on fractions is done in primary, the application of body mass is also done in primary, identifying what we call proper, improper, and mixed fractions is again done in primary school mathematics. And then we have what we call order of operation, which is also done in primary school mathematics. But there are only few things, actually two subtopics that are incorporated in Form 1, which makes it a bit different from what is covered in primary. And that is what I want us to discuss in our lesson today. So what are these two items? The two items that we want to discuss today is one, we call it recurring decimals. And then number two, we'll discuss word problems. So these are the two things that students need to look at it carefully when they are revising on fractions, especially if you expect to get any mark in paper 1 for mathematics. So what we need to know is what are recurring fractions. Now students, you'll understand that we have what we call conversion of fractions to decimals. Conversion of fractions to decimals. This is a subtopic that comes before recurring decimals, where we are given a fraction to convert it to a decimal. And what we do is we carry out what we call long division process. For example, if you are told to express each of the following as decimals, and you have a fraction 2 over 5. So this fraction can be expressed as a decimal by carrying out long division process. So we take 5, we divide by 2, or 2 divided by 5. 5 cannot divide 2, so we write 0 on top of 2. And then we add a 0 to 2 to make it 20 and put a decimal point. Then 5 into 20 is 4, so that we have 4 by 5 is 20, a difference of 0. So the solution becomes 0.4. We shall have expressed 2 over 5 as a decimal. If we have a second case, let's say, for example, we have 3 over 8. We are told to express 3 over 8 as a decimal. Again, we shall take 8, we divide it into 3. 8 cannot divide 3, so we write 0 and put a decimal point, add a 0 to 3 to make it 30. 8 into 30, it is 3 times, so that we have 24, a difference of 6. We add 0. 8 into 60, 7 times. 7 times 8, that is 56, a difference of 4. Add 0. 8 into 40, 5, because of 40, a difference of 0. So it becomes 0.375. So 3 over 8 as a decimal is 0.375. You'll realize that in the first example, 2 over 5, when you divide it, you get a complete solution. That is 0.4. Similarly, 3 over 8, if you divide, you get 0.375. And that is the decimal. But there are other decimals, like let's look at C, where we have, for example, 1 over 3. If we divide 1 over 3, then we shall have 3 into 1. 3 into 1 is 0. We add a 0 to make it 10 and put a decimal point. Then 3 into 10, 3 times. That is 9, a difference of 1. Add 0, 3 times. 9, a difference of 1. Add 0, 3 times. 9, a difference of 1. So it will be a repetitive decimal, where 3 will keep on appearing. Now, this kind of a situation is what we refer to as recurring decimals. Decimals that do not terminate when you carry out division. So what we do is, for this case of 0.3, this one is what we call a recurring decimal. A recurring decimal. So mathematically, when we talk of recurring decimals, these are simply decimals where a digit or a set of digits keeps on repeating themselves in the number during division. And as in this case, 3 is repeating itself. So we now write 0.3 with a dot on top of 3. So instead of writing 0.333, where 3 is recurring, simply write 0.3 and put a dot on top of that digit that is recurring. For example, again, if for example I have 0.7777 and 7 is recurring, then I will simply write 0.7 with a dot on top of 7. That means that 7 is recurring, or 7 is repeating itself. If we have 5.23 and 2 and 3 are repeating themselves, so we shall have 2, 3, 2, 3, 2, 3. Then this one, we write it as 5.23 and put a dot on top of 2 and 3, because 2 and 3 are recurring. What about if we have this case? 0.693693693. How do you write this? How do you write this? When 3 digits are recurring, then what we write is we put a dot on top of the first digit and the last digit. So when you find a situation whereby there is a dot on top of 6 and 3, and there is 9 in between, that means all these digits are recurring. So when there are 3 digits recurring, we may not put the dots on all the digits, but rather we put the dot on the first and the last digit, so that to mean all of them are recurring. Therefore, students, recurring decimals exist as in three ways. One, we have a case where there is 1 digit recurring, there are 2 digits recurring, or there are 3 digits recurring. Other cases for 4 digits recurring exist, but we don't look at them in Form 1 mathematics. So when you concentrate on recurring decimals, only focus on the 1 digit recurring, 2 digits recurring, and 3 digits recurring. And that is how we represent the recurring decimals, by putting a dot on top of the digit that is recurring, or on top of the digits that are recurring. So in this lesson, what I want us to know is, when we are given recurring decimals, are we able now to get back to the fractions? Because our topic is fraction, not decimals. So we'll be given a recurring decimal to bring it back to fractions. So how do we work it out? That is our subtopic, expressing recurring decimals. Recurring decimals as fractions. Recurring decimals as fractions. Now you will need to note that in the topic decimals, we give what we call place value of decimal numbers. And place value of decimal numbers, remember a decimal number is a number that has two parts. We have the whole number part and the decimal part. So at the beginning of the decimal part, we give place value from the 10th onwards. And from the whole number part, after the decimal point, we give the whole place value from ones onwards. So the 10th, 100th, 1000th, 10,000th helps us now to be able to work out what we call expression of recurring decimals into fractions. But what we shall always be required to know is how many decimal places do you have? Because the number of decimal places will determine what you are going to carry out in this case. And so we shall look at this part in three. One, where you have one digit recurring, where one digit is recurring. So, for example, you are told this way. You are told to express the following fraction, the following decimals as fractions. Following decimals as fractions. The first one we have is 5.5 with a dot on 5. One digit is recurring. The procedure for this is simple. What you need to do is you have to write what we call a recurring expression or equation. A recurring decimal expression will be written by, let's say, our recurring decimal will be 5.555. You can write as many 5 as you want, and let that be equation number 1. And then number 2, ask yourself, how many decimal places are here? It is one decimal place. And so that gives its place value to the nearest 10th. So what we do, we multiply this by 10 to make it 10R. Then this means we move one step ahead to have 55.555. And that is the second equation. Now you take the second equation and the first equation you subtract. So you subtract 1 from 2. Subtract 1 from 2 to mean you have 10R is equals to 55.555 and R is equals to 5.555. And the reason why we are subtracting is to ensure we have a whole number on the right side of the equation. So when you subtract this, 0, 0, 0, then this gives us 5 minus 5 is 0, then this is 5. 10 minus 1, 9R. So how do you get R? R becomes 50 divided by 9. Now this is an improper fraction. We don't advocate writing final solutions as improper fractions. So we express this as a mixed fraction. So then we shall say 9 into 50. 9 into 50, that is 5, 45, a difference of 5. So you write it as 5 whole number, 5 over 9. That is the fraction that we obtain from 5.5 recurring. Step 1, form the recurring decimal equation. Step number 2, identify the number of decimal places and multiply the equivalent total value to the first equation. Then subtract the two equations and divide with the coefficient of R to get your fraction. What if you are given 0.7 with a dot on top of 7? implying that 7 is recurring. Shall do the same procedure. R will be 0.7777, and we are saying you can write as many 7 as you want. How many decimal places? 1. So that makes it 10 of R is 7.777, and that is equation number 2. And what we do is we subtract equation number 2 from equation number 1. So that is 1 from 2. We subtract 1 from 2. We subtract equation 1 from equation 2. So that will be 10R is equals to 7.7777, and R is 0.7777. 10 minus 1, that is 9R. Then this is 7. So our R is 7 over 9, and that is our fraction. So that is our second case. Students, there is a third case that may appear different from this one. And this is a case, for example, you are given 0.63, and there is a dot on 3. So yes, there are 2 decimal places, but there is a dot on only one of them. So how do you work out this case different from the first 2 cases? Procedure number 1, get the recurring decimal equation. So 0.63333, that is our equation 1. Question number 2 is, how many decimal places are here? That is 2. 2 will make it 100 because it's 100th. So 100 will mean we move 1, 2, so that we have 63.3333, equation 2. Then, if you look at these 2 cases, you subtract this, you will not get 0. So what have we kept in between? We've kept a place value 10R, which is equivalent to that digit that is recurring, one of them. So if you move this one more step, it becomes 6.3333, and that is equation number 3. So unlike in the first cases where we have only 2 equations, here we have 3. And we don't look at the first and the third, or the first and the second, but rather we look at the third and the second, because this is the only ones that can give you a 0 after the decimal point. So what you do now in this case, you subtract 3 from 2. Subtract equation 3 from equation 2. Equation 3 from equation 2. So what we shall have is 100R is 63.3333, and 10R is 6.3333. You subtract this, you'll have, this is 0. Now 13 minus 6 is 7. We are left with 5. And 100 minus 10, that is 90R. So what is R? R is 57 over 90. 3 can simplify. If you simplify by 3, you cancel, this is 1, this is 9, and this is 30. So the fraction is 19 over 30. That is the simplified fraction. I hope you will be able to note the difference here, that we have 3 equations in this case, and in the other cases we have only 2 equations. And the equations are based on the number of decimal places that exist in the decimal number that you've been given. So that is the first case, when one digit is recurring. Number 2, where 2 digits are recurring. Where 2 digits are recurring. Where 2 digits are recurring. So when the 2 digits are recurring, then what we look at is the same situation for the recurring decimal equation. We are told to express each of the following recurring decimals as fractions in their simplest form. In their simplest form. So we have 0.46, a dot on 6, a dot on 4, meaning that 4 and 6 are recurring. So students, we start again our procedure. Solution. Our recurring decimal will be 0.464646, and you can write as many as you want. That is the first equation. How many decimal places? 2. In the original number, there are 2. Therefore, we go for 100R. 100R will be 46.464646. Equation number 2. If you look at this and this, question 1 and question 2, you can subtract and obtain a 0. So what you do is you subtract equation 1 from 2. Subtract 1 from 2. That is to mean 100R is equivalent to 46.4646, and R equivalent to 0.4646. If you subtract this, you end up with 46 on this side, and this side you have 99R. So if 99R is 46, what is R? R will be 46 over 99. 46 over 99, that's a simplified fraction, because you can't simplify beyond that. So that becomes the solution for our first case, where 4 and 6 are recurring. Where 4 and 6 are recurring. What about this case? Let's try 1.23. 1.23 recurring. Let's try 1.23 recurring. Step number 1. Our R becomes 1.232323. Equation 1. How many decimal places? 2. So we go to 100 of R. Now we move 2 decimal places. 1, 2, 123.2323. Question number 2. Then what do? We subtract 1 from 2. Subtract 1 from 2. So that means 100 of R is 123.2323, and R is 1.2323. Subtract this. 100R minus R, 999, that is 99R. Then this is 0. So this is 2, this is 2, and this is 1. So how do you get R? We divide this one by 99. Divide this by 99. So that this cancel out, and our R is 122 over 99. That's an improper fraction, And we say you don't give improper fractions as final solutions unless asked so. So what you do, we take 99 into 122. 199 into 122 is 1 because of 99. Then we have 12, 3, 11, 2. So it is one whole number, 23 over 99. That is the fraction. So that is our case number 2, where 2 digits are recurring. Our last part should be where 3 digits are recurring. What do you do when 3 digits are recurring? Where 3 digits are recurring. Where 3 digits are recurring. Remember, we've said when 3 digits are recurring, we don't put the dot on all the digits, but rather we look at only the first and the last digit. You are told to express each of the following recurring decimals as fractions. So the first one we have is 0.825, and put a dot on top of 8 and a dot on top of 5 to mean that all of them are recurring. So what you do, just as we've done before, identify the recurring decimal equation. So R will be equal to, R here stands for recurring decimal. It will become 0.825, 825, 825. As we've always said, write as many as you want. And then how many decimal places are here? There are 3. So you multiply by 1,000 because that gives us a thousandth. So 1,000 of R becomes 825. Someone may be wondering why 825. When you multiply by 1,000, it means you move this decimal point 3 steps to the right. So you move it 1, 2, and 3. That's why 825.825.825, and that is our equation number 2. Then the next step is you subtract 1 from 2. Subtract 1 from 2. So you have 1,000. R is 825.825.825, and R is 0.825.825. Get the difference of this. You realize that after the decimal, it's 0.0 because this is 0, 0, 0, 0, 0, 0. So we have 5, 2, and 8 equal to 1,000 minus 1R is 999R. 999R. So then what do we do to get a fraction? We divide both sides by 999. So that we have now 9, R is equals to 825 divided by 999. This can be simplified further because 3 can divide 825. If you divide by 3, you have 2, 22, that is 7, and that is 5 by 3, that is 333. That is 9, 9 plus 5, 14, so it cannot be simplified any further. So write 275 over 333 as our fraction. That is how we get for the 3 digits recurring. And maybe lastly, we can now try this one, where we have 2.715. And the dot is on 7 and on dot of 5. Same procedure. What is our recurring decimal? Becomes 2.715, 715, 715. The first equation. Then what you do, identify the number of decimal places. There are 3. So you multiply by 1,000 of R to make it 2715.715715. Then finally you subtract 1 from 2, so that you have 1,000 of R is 2715.715715. Subtract R, which is 2.715715. So when you subtract this, you get this is 0. Then 5 minus 2 is 3. So we have 7. This is 1, 7, 2. Then this is 999R. Then we divide by 999. So R becomes 2713 over 999. Can it be simplified by 3? Let's see. This is 10, 11, 14. It can't. So what you do, you take 999 into 2713. If you divide, you get this is 2. 2 because of 18. 18, 9, 18, 9. So you subtract this. This is 13, 5. You are left with 0, 10, 1, 6, 16, 7. So the solution is 2 whole number, 715 over 999. And that is our fraction. So students, that is what we need to know in recurring decimals. That understand a recurring decimal is a non-terminating decimal. That when you divide certain fractions, changing them to decimals, they give a number that does not come to an end, a decimal number, where either a digit or a set of digits keeps on recurring or repeating in the number. That's what we call a recurring decimal. And we've said that you represent recurring decimals by writing a dot on top of the digit recurring. So if a digit is, for example, 7 is recurring in a number 4.7, then you put a dot on top of 7. And you'll find in recurring decimal, the digits that are repeating will always be after the decimal place. There's no way where 4 will be recurring, and we call this a recurring decimal. So you only put it after the decimal point. Then we have 3 kinds of decimals that are recurring. We have 1 decimal number recurring, 2 digits that are recurring, or 3 digits that are recurring. For each of them, if you want to express them as fractions, the first thing that you must always do is to write what we call the recurring decimal equation, that is given by how that decimal is appearing when you write it in the way it's supposed to be, excluding the dot on top of that digit that is recurring. Then the second equation is obtained by looking at how many decimal places are given in the original recurring decimal. If it is 1, then you have to go into the 10th total value, which is 10. You multiply by 10. If it is 2, you multiply by 100. And if there are 3, you multiply by 1,000. Then you do the subtraction of those 2 equations to get your decimal and the whole number, which then you divide to get what we call a fraction. So those are the things that we were to look in recurring decimals. Now, if we had time, we would have looked at the last part, which is more involving, that we call the word problems. But perhaps we shall look at the word problems in our next lesson, so that we see how do we understand or analyze word problems in fractions and bring them to reality, because that is what most of the students don't know. They always know about body mass. if you give them this question to evaluate, if you ask students evaluate this, 3 over 5 of 1.5 plus 3 over 10 minus 1.25 of 3, they will work it out so well because they know something we call board mass. But the moment you give a word statement that has fraction, then they don't even read. They think that is now something else, not mathematics. They want just to see direct figures as written this way. So that's why we shall now spend more time on fractions and look at what we call word problems and see how do we understand or interpret word problems and work out mathematically applying board mass and a few areas that we may know in mathematics that are in fractions. So until next time, when we shall meet again, I've been your teacher, Mr. Ndenga-Global. Thank you.